No, I'm just kidding. Especially at 5 p.m., even I want you guys to be punctual. So at C dot, I had really good lunch. Now the game we are going to play is whether I doze off because of that heavy lunch, or you guys doze off because of my talk before that, right? Let's see sort of this game we are going to play.
Good evening, everyone. Welcome to the Network Seminar Series hosted by the Center for Networked Intelligence at the ECE and RBCCPS IISc. It's my pleasure to introduce today's speaker, Dr. Puneet Sharma, and he will be speaking on Rethinking Networking through the lens of AI. Dr. Puneet Sharma is a HPE Fellow, Vice President, and the Director of Networking at the Distributed Systems Lab at HPE Labs, leading research in Edge to Cloud to Exascale infrastructure, multi-cloud resource orchestration, AI for infrastructure, 5G, Wi-Fi, and security. Since joining HP Labs in 1998, after earning his PhD from the University of Southern California, he has driven innovations in software-defined networking, GPU virtualization, container orchestration, edge computing, private 5G, and AI/ML systems, enabling major technology transfers across HPE business units. A recognized global thought leader, Puneet has authored 150 plus papers, holds 90 plus patents, co-authored IETF RFCs, and delivered keynote talks at IEEE and industry events. He is an IEEE fellow, ACM distinguished scientist, and two-time Singhua AI 2000 most influential scholar. He earned his BTech from IIT Delhi. His leadership continues to advance AI-powered distributed computing and networking infrastructure worldwide. Over to you, sir.
Thank you. Um, I don't know if you guys stay this long on campus or not, whether I'm sort of in between your next metro ride back home. And so I will try to sort of give you a bit of perspective on how AI is actually being used for making networks smarter. Primarily, I'm going to sort of touch on two papers that we recently published. The Wixor paper, which was in CONEX 2024, is about use of AI to do dynamic TDD. I will talk about what TDD and things are, how we are using it. And then the other paper that we recently presented in Hong Kong at CONEX 2025 called Maestro, which is about using AI to actually do quality of experience for Wi-Fi and so on, right? So again, I hope I'm not the only one who you have heard about AI from and things like that. It seems to be that AI is going to eat the world and things, right? So um, I come from the world where I grew up watching James Bond movies and things. Does this remind you of anything? Bond coming and saying, name is Bond, James Bond, intelligence, artificial intelligence, yeah. So I'm going to throw a lot of Bond references as I sort of go through. Again, the effort is to figure out who sleeps faster, right? Me or you guys? So jokes aside, when I talk about sort of rethinking of networks in the era of AI and so on, right? I mean, networks basically are not just built because they're not like homes or castles and stuff which have the other identity, or even actually homes, there's a purpose to that, right? Similarly, networks are built to support different applications. Initially, it was probably some telnet and logging in and so on, to all these nice applications that have come, Zoom, that this talk actually is being carried on as well, YouTube, Netflix, Insta Reels, right? I mean, then networks actually support those things as well. And the reason I actually sort of bring that up is that the time there's a lot of these networks are actually sort of built and designed, a lot of these applications are not even there. And they all have different notion of quality of experience. So for the longest time, and I joined HP slash HPE in the last century, 1998, right? Since then, most of the management and control of networks is being done by actually managing or optimizing for what I call literally dry networking metrics, right? The latency, the bandwidth, the jitter loss, right? So that's what we try to sort of say, look, I have increased the network bandwidth from 10 Mbps to 100 Mbps. Does that matter? And how will that actually sort of affect my quality of experience when I'm doing all those rich applications that I was talking to you about, right? I mean, or I reduce the latency by these many milliseconds. Will it have impact on my Zoom call? Maybe yes, but how much? We don't know, right? So, and the reason actually sort of is that all this we have not sort of, we are primarily so focused and stuck with these network metrics and things that we ignore what the impact on the quality of experience is, right? And sort of in the most layman form, if you think about quality of experience, this is how you and I at the end of the sort of Zoom call or a WhatsApp call or a Teams meeting will say, look, was your experience good, right? The subjectiveness of that and so on. So some of you who actually sort of were have lived the life before cell phones and things would actually remember, right, and have been in this networking business. There is something called mean opinion score to judge the quality of your phone calls, right? And the basically what was done for simple audio sort of that is being carried in these phone calls, you would figure out what the R factor is. You actually sort of take the average round trip time, turn that into R factor, then you sort of take that loss rate, right? These dry metrics that I was talking to you about, you convert that R factor, and then based on what the value of the final R is, you convert that R to mean opinion score, and that becomes your quality of experience, right? Because if you think of audio call as a session or media, there is only so much to that quality of experience that you can sort of expect from, and it's fairly simple. Over the years, people sort of figured out, look, ITU said this is how you sort of compute it, and this is what your quality of experience is, and it worked fairly well. Now, with all these sort of newer applications that I was talking to you about, from YouTube to Zoom calls and file downloads and whatnot, there has been some connection, but there is also, if you look at some of this previous work, basically QoS does not necessarily translate into the quality of experience. It's not sort of, it's not as simple equation as I was showing you about going from these network metrics to the mean opinion score for audio call, right? Because even if you forget everything in a Zoom call, there is an audio session, there is the slide sharing which is going on, and the video session that is going on, right? So the whole quality of experience is a subjective metric based on all these different sessions and things also. So going about that, right? So now there are all these AR, VR applications where the quality of experience not only depends on what is happening on the network, it also depends on what kind of devices are you sort of using it for, what are the other interactions and so on. Now all these sessions are being carried on Wi-Fi, let's assume for a little. Then the Wi-Fi itself has all these different control parameters that you can actually sort of change, from channel width to what the PHY MAC mode is, the access categories and priority queues and so on. Similarly, the channel width itself has multiple sort of values it can sort of be configured at. The MAC mode is high throughput, very high throughput and high efficiency. The access categories are whether it is background traffic, best effort, video, voice, and so on. Some of you who have worked on Wi-Fi would actually remember something called WMM, right, which basically sort of assigns these different priority levels or these access categories for different flows that are coming into the system. One of the easiest way to actually think about this category, and the reason I want to spend a little more time on the access category here, is that we'll be using some of these control parameters to improve the quality of experience as I walk you through, is that these access categories are sort of in decreasing order of priority from this side to that side. So I don't know about here, but in US there are these HOV lanes or the carpool lanes, where you actually sort of, if there are more people in that lane, then they can go faster because there are only sort of restrictions on who can use that lane. And in some ways these access categories are very similar to the priority lanes that you will see on your freeways and highways and so forth. It works well as long as what happened to me in Bay Area doesn't happen to you, where I was the only one who was driving my Honda Accord. Rest of everybody switched to Tesla. And the government said, we will allow Tesla to sort of use the HOV lanes also. Right? And the reason I say this is that now I was the sole sort of person driving Honda Accord who had all the 4 lanes, whereas all the EVs were driving in that one single sort of high priority HOV lane. Who's higher priority? Right? And so in some ways what had happened was that though the prioritization was okay, it was not getting you the intended sort of outcome and so on, because you had moved your congestion from sort of these other lanes to one single lane and so on. And I mean, of course, the thing that I said is exaggeration, but even think of it this way: if you have 2 video calls, they both basically sort of go to the high priority, then all you have done is to sort of change the interference from one lane to some other lane, right? They will still sort of interfere and so on. There is no sort of separation and segregation that is going to happen there. There is also sort of queues, high priority, low priority that you can do and so on. So, right? So there are all these parameters in Wi-Fi, that all these applications, and I will sort of flash through a lot of this sort of, there are point clouds, there are moving point clouds and so on, and the bandwidths that they sort of take are very different, from 14 Mbps to 400 Mbps. There are other applications like volumetric 3D texture rendering and so on, which again has similar frame rate, but the bandwidth is actually sort of much lower and so on. There is, of course, everybody who has worked in this space for some time is familiar with available bitrate and ABR video traffic and so on, right? So again, there is this bandwidth stuff. Now video conferencing and so on has happened. The bandwidth that you will see actually changes with the cameras and the feeds that you are sending and so on. The reason I sort of showed you a lot of these applications was to be able to say that, look, the quality of experience for each of these applications varies. The audio call was actually sort of very nicely done. There have been actually sort of papers, for example, NSDI 2020 takes the volumetric streaming that I have, and they, based on some of these criterias like the point density, visibility and so on, and stalls, they came up with, look, how will you compute the quality of experience there. Similarly, ABR QoE sort of, right, SIGCOM 14, they actually sort of, so all these applications have different way of figuring out what the quality of experience is, because it takes a lot to go from these dry metrics to a subjective notion of the quality of experience, because we are talking about how humans, or how the sort of session quality is being perceived by the humans and so on. Similarly, video conferencing and so on. So this was paper at one of SIGCOM workshops, I think it was 2022, oh no, 2023, where we basically took all those Wi-Fi parameters that I showed you. We took all these applications that we sort of did also, and then trained our models to be able to actually sort of figure out, was there relationship? Can I actually sort of use these network metrics that I can monitor at access points and so on, to be able to predict what the quality of experience will be and so on. And partly what you can actually sort of see is that if I change the channel bandwidth and so on. Um, the the normalized sort of there's correlation between the QoE and the available transmission buffer. This is for the moving point clouds, right? Similarly, you will actually sort of figure out other relationships with the other applications and so on. Similarly, the number of retransmitted frames that were there, that's inversely proportional to the quality of experience that you will be seeing and so on. So can I actually sort of figure out what that relationship is there and so on, and these become sort of really complicated. I remember that MOS calculation formula that I showed earlier, that was fairly simple and so on. So yes, this is actually sort of a ground truth from either what the application is reporting to us or human sort of data points which are telling you this is what my quality of experience is. This is the ground truth. Yes. So again, very good. So, right, so basically for each of the application, that what you are calling perceptual evaluation varies, right? And that's what some of you have to decide how you're going to define that quality of experience. I'm not sort of in the business of saying, look, this is what it is, right? What I am actually sort of saying is, if those relationships are not very clear, AI models are a good way to be able to take all these features and then be able to tell you. I will train a model based on whatever your notion of ground truth is. I don't want to question that ground truth because Zoom people might not actually agree with Teams' way of what the quality of experience is. Right? So I don't want to sort of get into whether I'm doing the perceptual sort of video quality, the size, how many times it's actually fluctuating and things like that. That's the ground truth. That's the notion which I leave to the application person.
So you are expecting the application user to level the data so that you can.
Yes, so I will only sort of say, I would not actually sort of say the user, whoever the application vendor or the application authority, so to say, is. Right? It's not you and me in some way. That's the only distinction.
Okay.
Yeah. So, and that's a very good point, right? What I'm saying is that calculation from the latency loss and so on that I was able to do for doing the MOS, because there also they basically sort of figured it out based on how they basically ran all these tests and things, right? So similarly here also I will figure out what my ground truth is, and then I will run this stuff. So any Bond fans here? No martini people either? Who knows the difference between a shaken martini and a stirred martini? Oh man, I should have actually sort of gone with some other movie reference and things. But basically Bond prefers shaken martini, and for the purposes of this talk, the shaken martini is cloudy, the stirred martini is clear, right? So the R to MOS score calculations that I was talking about, that's very similar to the stirred martini, right? All these sort of fancy applications today that we were talking about where we cannot agree, that's the shaken martini, right? So because I didn't want this talk to be just about, look, here is the paper we sort of present. I wanted to also sort of like, what have I learned from this experience of building these applications and how to use and how do I rethink the network design and so on, right? So very similar to Bond's choice of martini. The takeaway from here is that use AI when those things are not clear, when it's cloudy and things like that. That's what these models are actually sort of good training grounds for. And you might basically sort of say, look, what does this shaken martini mean for you in this particular case? We actually sort of built a LSTM model, trained it on taking all those QoS metrics that I was talking to about. We had the ground truth as you were sort of from these applications and so on, and it sort of brings this up, and then I can actually sort of estimate what my quality of experience is. Right? So now, without actually getting explicit QoE signaling from these devices, which are the endpoints and so on, I can sit in the network, collect or monitor these things and then be able to sort of predict what my quality of experience is going to be, right? So now, how do I actually sort of then bring that QoE awareness to the Wi-Fi networks, and what can I actually sort of do, right? Because the goal is to improve that quality of experience. I don't want to sort of just say, look, I reduced the network latency for everybody by this much, because even some of that might not be in our control and so on. So we take these quality of service metrics. Can I actually sort of configure the flows in particular manner to improve the QoE without that explicit sort of QoE? And the reason why I want to sort of not use this is because whole lot of times as a network operator, I don't actually have access to it, right? You guys all walked in to the room. Some of you are sort of seeing this on Zoom and so on. I don't expect you to tell me, look, how is the quality of experience and so on. I want it to be sort of automatically done and so on. So that's where Maestro actually comes up. And we were discussing intent earlier, Preetham, right? The two intents that I have in this particular work were, I want to be able to maximize QoE, the whole system QoE per se, and also QoE fairness, right? Because again, going back to the analogy of HOV lanes and stuff, I don't want to sort of, I want to prioritize things or sort of give spatial treatment to some of the packets, but I still want to balance that with the quality of experience deterioration for the other flows that might be in the system also. So we take QoS metrics, we do flow configuration with those are the goals that we are after. It has two parts. I talked already about the AI powered QoE estimator, right? That LSTM model that I was building. And then using that estimator, I actually sort of do AI powered resource allocator also, right? And I will talk about what my resource allocator actually sort of does and so on. So the resource allocator is basically sort of working in this dynamic heterogeneous environment, because there are all kinds of different flows that are there. Flows are coming in, they are going, and so on. The search space is complex. So what we use is what is an AI technique called reinforcement learning, which takes different QoE values, and there is an agent which will basically sort of do reward regret, and then be able to say whether you can actually sort of use these, do you want to sort of do the QoE and stuff like that. There are multiple agents for each of these flows, and the idea is, can I actually increase the quality of experience for all the clients or the flows that are there in the system. Of all the different things for the Wi-Fi action space that I actually sort of talked about, in this particular work, I'm only using the access category and the flow priority. I'm only sort of playing with two knobs, right? Just to be able to demonstrate what is possible. You can actually sort of increase your action space, make it more complex and do all. Right now, I'm only using two, right? But architecturally, I'm not sort of saying that you cannot use other sort of parameters to do this also. You'll have to change your reinforcement learning and so on. So you might basically say, look, work and so on. So I have a streaming flow that comes in, and Maestro says, look, this is streaming flow. I should act like the HOV lane. I will give it the highest priority. I would give it the topmost access category of video, and send this. As a result, now I can actually sort of predict what the quality of experience for this particular flow is going to be, right? At some later stage, a file download flow happens. And now I want to sort of say, look, oh, file download, lowest category, best effort, lowest priority, best effort, and that's what I should give, because that's what the default stuff is. And then I actually have some amount of quality of experience for this file download also. And of course, we can get into how do you normalize the quality of experience across different flows and things like that. Assume everything has been normalized on a scale to 1 to 10 or 0 to 1, whatever your favorite sort of markers are, and so on. So now, as I said, right, we want to be able to increase the overall system quality of experience also, not just individual so on. And then, because we earlier were having these discussions about the SLAs and the thresholds and things and so on. So what I can actually sort of, Maestro basically says, oh, there is only one flow, I don't need to necessarily sort of put it in the fastest lane. I can sort of reduce that to lower priority video. And now my file download will actually sort of, so even though the quality of experience for my streaming video actually sort of went down a little, but I was able to sort of bring up the sort of the quality of experience for the file download significantly, right? So overall system sort of, so this gives you example of how when the new flows come in and so how Maestro will periodically evaluate this. So the predictor will tell you, look, if I take this action, this is what the quality of experience is going to be. I send it through the reinforcement learning engine, it tells me the action, and then I sort of keep on repeating, rinse, repeat, rinse, repeat, rinse, repeat. So now the question is, can I actually sort of, what were some of the numbers that we sort of see? So we got four different application types on the QoE: Zoom, YouTube, OneDrive, Netflix. OneDrive is equivalent to sort of file downloads. Netflix and YouTube are video streaming services. Zoom is more interactive and so on. WMM that I was telling you about, right, which basically sort of gives you fixed prioritization on these different flows and different kinds of flows. So what WMM does is that it expects that you will mark the flow as a particular video conferencing flow or a streaming flow. It will assign that same category all the time. This is very similar to, again, that HOV lane policy where everybody who is sort of multiple people will go irrespective of whether they have to get off the next exit or not, right? So Maestro was able to actually sort of do much better, especially YouTube kind of scenarios. We were able to go up by 42%, and then you would basically say, look, you had two objectives, Puneet, not just one, right? You wanted to the quality of experience, fairness across these different flows and so on. So again, we actually sort of not only improve the overall system quality of experience, we actually sort of improve the fairness across these different flows and things also, if you wanted to. Yes. So I think that's actually a very good question. Like, this is again based on the normalized QoE value that we sort of use standard fairness mechanisms and so on. Yes. No. So I think part of it is also how that reinforcement learning engine, we did not ask it to sort of fare, because the reward functions were so set that we would maximize the system QoE, and it sort of, right, I think partly also because there is not much improvement in terms of maximization that you can do with respect. Netflix already had higher quality of experience. So the reinforcement learning engine was trying to actually sort of up the YouTube as much as it could. So, and again, take this with the kind of improvements that you will see will depend on your mix of traffic and things like that. Right now, there are only single flows in each of these categories. What I'm going to do with Maestro is to actually, even within each Zoom call, treat each of these different Zoom calls differently. Like, so I'm not deciding it on a per application category also. I'm taking these actions for each of the flows. But very good point. Basically, this is already sort of very high. This goes up. I think there was a question first here, then I will come to you.
So this fairness is across the application, not across
Yes.
the users.
Yes. Well, actually, across the users, because I'm finally sort of here, users is equal to applications because there is only one flow for each of these applications. But if there are multiple flows of each of these applications, then the fairness is going to be across all the users. So think of them not in terms of users or applications, think of them as a flows.
So a lot of experience also depends on the placement of the user. So if a
What do you
user is
mean?
badly placed, maybe towards the cell edge,
Yes.
where there is inter-cell interference, so how do we deal that kind of, because one of the user may mess up the entire quality of experience matrix here.
Yes, right. So again, it's the fairness is one of the objectives, not the only objective. right? So the goal is to up the system quality of experience as much as you can without actually messing up the fairness, right? That poor user that you are talking about, there is not much that I will be able to do to bring it down, right? So I would still be okay. If I would be unfair if there was a good user that I was unnecessarily punishing. Yeah.
So I understand the improvement, but where are we seeing the degradation? I mean, if we only have enough resources.
We so that's actually a sort of very good question. Let me sort of again sort of show you from the example. Actually, one of the previous slides, there is this degradation in the quality of experience when I sort of change this down below. So there will be, I mean, basically it's a zero-sum game, right? And that's what you are sort of coming. So I'm not saying that. So basically, what happens, and if you're basically saying is, look, you improved everything and so on, how is that a zero-sum game, right? That's probably what you are getting at. The question is that I was unnecessarily sort of pushing the YouTube down by keeping this up. Right? It's still zero-sum. I can't sort of, but the, you know how the priority queues work with sort of strict priority queues where I will not serve packets from the lower priority queue till I'm sort of sending things from the higher priority queues and so on, right? So what most likely happened here was that we degraded the quality of experience for not quality of experience, we reduced the priority queues here, and hence this was able to sort of get much more.
But again, in QoE, the impact of degradation differs from application again.
Yes.
So yeah, I mean,
We are basically normalizing everything on a scale of 0 to. So we'll take those application QoEs as we were discussing earlier based on the ground truth and so on, and then we'll normalize that on scale of 1 to 0 to 1 or whatever the normalized scale is. And then the fairness calculation or the maximization and stuff is all on that normalized scale. Yeah.
Yeah, so are these all users connected to single AP, or are we talking of
Right now, single AP.
Okay. So will you talk about
We haven't actually sort
management
of,
across
this
cells?
paper did not cover multiple APs and things like that, but you can potentially sort of, that's an interesting space. We don't have experimental data on some of this, but that's some of the next step things we are working on. So now we were basically talking about, right, the continuous feedback from the user and things like that. Earlier today, when I was giving a similar talk at CDOT, one person actually asked, we normally sort of, if our quality of experience is bad, that's when we leave the reviews. If the quality of experience is good, then we don't leave the review. So that's equivalent to the explicit QoE stuff, right? If the user was sort of continuously telling, so for example, if I had a monkey who was sort of continuously telling you what my quality of experience and things is. So we wanted to also compare, again, same applications. We do better than explicit QoE. The reason I want to show this graph is because it actually sort of two things. One, it shows you that the two parts for Maestro, right? The reinforcement learning engine, which is taking the actions in the control loop. Then the other is the one which is predicting the QoE and so on, right? And what this shows is that even if I was not predicting the QoE, and if I had explicit QoE interaction and so on, could I have actually sort of done better or not, right? So this shows if I had the best information possible, my reinforcement learning engine can actually sort of do much better. The other thing that I want to actually sort of, the takeaway I want is that the QoE estimator that we have, right, the normal tendency is to build the most accurate estimator that you can, right? So we were sort of stuck doing some of this also. It's like, oh, 90 sort of % accuracy in my QoE estimation and so on. Is this model good enough? And the quality of the model here should have been evaluated not in terms of the accuracy. So if I am basically sort of taking some decisions based on this estimation, and those actions and decisions are exactly the same irrespective of what my predictions are, the good enough model is good. I don't need sort of 100% accurate estimation model in this particular case. Since I use analogies a lot, here is an analogy, right? If I had to draw a Google map, I need to know exactly where different buildings are, right? But if I had to actually find the fastest route between two buildings, the location of those buildings don't have to be absolutely accurate, as long as I broadly know how I can sort of go around those buildings and so on, right? So the reinforcement learning and the action stuff, as long as my action are sort of optimizing the outcome with respect to quality of experience, my model is good enough. I don't need much more accurate model if that's what. So this is what this particular graph is actually sort of saying. Look, even if it is not 100% accurate or 99.9999% accurate, it's good enough to sort of give you that bump in the quality of experience that you were looking for. As you can actually sort of see, Maestro basically sort of does fairly close to what the explicit QoE would have actually sort of done, right? It's not 100% prediction accurate model. And this sort of brings back to me to Bond again. Whole lot of times Bond blows up the enemies and things. He just sort of looks at his watch and says, presses a button, everything is gone, and then he makes this sort of punny comment like, I just showed somebody my watch and it blew their mind, right? So this is to basically say that, look, the results, the nice results that I was showing you about improving the system quality of experience, the fairness, and how well you can actually do is not just credit to AI or how we actually sort of used AI to do this. There was careful design of the system that we talked about, right? We sort of figured out, look, how will we do the rewards and regrets in the reinforcement learning engine. We figured out, look, we have to actually predict the QoE, and that's what we want to optimize for, and so on. So Bond is cool, but cooler than Bond is actually Q, who designs all these watches to blow people's minds, right? That's sort of the message. So it's not, don't sort of suddenly, if you have wonderful results, don't sort of start creating temples of AI and things like that. It's your careful design and using those AI tools that made it happen. And similarly, don't sort of complain, look, AI is worthless if some things don't work. Either the problem is not AI compatible, so to say, or you probably need to sort of design your system better, right? So we are sort of again working with multiple access points, training the classification and things. Also trying to actually sort of, this goes back to your question or your comment about, look, where is the sort of ground to training and how will you train your models as the new applications are coming in and so on. So we are also building on sort of how will we collect, because for building that LSTM model, we have to collect tons of data for all these applications and train these models, right? We want to be able to actually sort of synthetically generate and use Gen AI models to be able to train some of these models and things also. And if you are a Bond buff like me, when Sean Connery retired from the Bond movies. They had George as the sort of next Bond, and he in the movie actually sort of makes it. This did used to happen to the other fellow, right? And it's not that he was less cool Bond. The point I want to make is that as you go from Wi-Fi 6 to Wi-Fi 7, your action spaces change and all. It's not that Bond has gotten any less cool. It's like you have to actually sort of design these systems, rethink some of these systems. So magic is not, AI is not going to cure all these things by magic. You will have to sort of, again, rethink some of this. So don't complain. So just get down, do the hard grind and things. This actually relates to one of the other discussions we were having earlier today, where I was saying, look, this is the reason why AI won't take away our jobs. Because these systems will have to be carefully thought about and redesigned and things also as things really change. Changing gears, sort of going from Wi-Fi to private 5G and things, right? So again, going back to the applications we have on our phones and so on, mostly this spectrum that you have to be able to transmit and receive packets and so on needs to be split into what the uplink bandwidth is and what the downlink bandwidth is, right? And for the cell phone providers and so on, most of the cell phone providers, whether it is sort of AT&T, Verizon, and so on in US, or Geos and Airtels here in India, they basically think, oh, we are all sort of consumers of media. They normally sort of would take 80% of the bandwidth and then allocate it to downlink, and only 20% for uplink. Yeah. And I will come to why some of that might be accelerated. Again, it goes back to the applications. Now, everybody is a content creator also. How many of you upload Insta Reels and so on, right? So now suddenly we are not just watching Insta Reels, we are actually uploading a lot of Insta Reels also. So now suddenly that 80-20 thing that everybody is doing is already seeing some amount of tension. Yeah. The other way to sort of take that spectrum, instead of using just the frequency and divide the frequency for uplink downlink, is what is called TDD, time division duplex, which basically takes the time and then splits that into uplink, downlink, uplink, downlink, uplink, downlink. There is this notion of slotting that you can do. D stands for downlink, U stands for uplink. You see less of U's, more D's, right? More downlink, less uplink. S is spatial. You can use it for anything that you want and so on. The S is also used for what is called these guard intervals in between, because you can't sort of just you want to make sure that the signals actually, as you're switching from uplink to downlink, and right, unlike Wi-Fi, the cellular networks are much more sort of tightly controlled and orchestrated, right? I will actually sort of give you permission to transmit, unlike Wi-Fi, where sort of we just go clash and things and so on also, right? So this is TDD pattern. There is a policy which basically takes all these slots, and then that becomes a TDD policy. So now the question basically becomes, look, all these applications are changing and so on. Can I figure out what my TDD? So the standard actually allows you to change what these TDD policies are. This is dynamic. Nobody uses it. They basically statically figured out, nobody is sort of going to do Insta Reel. They don't know Puneet actually spends 24 hours just uploading Insta Reels. And nobody else can actually sort of use that upload bandwidth and so on, especially if there is a telesurgery kind of application which is happening, which needs the surgeon to operate on somebody and so on, right? My Insta Reel is now sort of competing with that surgeon trying to save somebody's life. Then the surgeon can't call me and say, shut up, Puneet, just no Insta Reels anymore. So how do you sort of figure this out, and what's the problem, right? Again, there is a lot of traffic load fluctuation itself, right? Suddenly everybody at night wants to upload Insta Reels, or in Bangalore traffic, if you are stuck at traffic lights, then you want to upload your Insta Reels and so on. So that can actually sort of cause a lot of problems. The other thing is that there are new applications like the surgeries or the augmented and mixed reality, which have sort of changed that ratio that you sort of had and so on. And it's not, I'm not just talking about at the course level itself, I'm talking about same the quality of experience that we were sort of after, right? For each of these flows, these mixes might actually change. So one of the other takeaways from my talk that I want you guys to have is that in most of the cases, we have actually started conflating AI and automation also. There's a bit of that smartness, but lot of the reason why things have actually worked this way is because the ability to be able to automatically control all these knobs, whether that was the FiMac or the priority and stuff, that automation itself has actually, Maestro was not just the reinforcement learning engine. There was basically, there is a programmable layer underneath that I can actually sort of build and do also. So what does Wixor actually, so that was the system we built. It has two pieces again. It basically sort of does what the demand for uplink and downlink bandwidth is, and then feeds that to figure out what policy or the TDD policy that I should actually sort of create. First step is to sort of do the demand customization, where I basically have this marker which tries to tell me how much uplink downlink bandwidth I should have, right? So I use all these channel quality, BS load, the traffic demand, QoS requirements, and so on, to be able to again train a model to be able to actually tell you what the resource forecasting is, to be able to tell you what the resource forecast will be and how should I sort of split it into uplink and downlink. That's the first step. The second step is basically sort of how do I, once I know how I should split, there is actually significant amount of policy choices that you have. Remember that guard interval, that it's not, shall I actually, let's say my demand was 50-50, right? I can do that by doing sort of downlink, uplink, or two downlinks, two uplinks, two downlink, two uplinks, and so on, right? But that guard interval is going to be in between. That is going to introduce some extra delays and things like that, which might actually sort of interfere with some of the other sort of things I have. And again, we once I know what percentages of uplink resources are, I sort of use that to figure out what the policies are. And then again, from the perspective of having more stable control loops and things like that, I do smoothing and other factors also. There is the sort of inter-sort delays that will actually sort of change your latencies and things, right? So again, the goal is not just to improve the bandwidth and so on, or the allocation to match the requirement. You don't want to have inordinate amount of delays and so on. The guard period overhead, how many guards do you sort of, because that switch thing that I was talking to you about, and then you sort of do the trade-off and balance to be able to do that. And now this is what Wixor actually sort of looks like, with these two interesting pieces and stages. To show you some of the results, we took sort of multiple scenarios of doing TDD. Static default is what happens today. Static fair is if you're trying to be fair between. Wixor is what we are, and so on. And what you will actually sort of see is that we were able to increase the network throughput, that's the lowest level, by about 30%. The latency went down by 65%, and then the buffer overflow incidents and things reduced. This was for video streaming, right? That also sort of went down by 84%. And then again, the goal is, and this sort of came up with our discussion with Preetham also, right? We are in the matchmaking business, right? We're going to sort of take all these requirements and things that are there, the mix of traffic, the awareness, and so on, and how do we sort of connect that with this, so it improves the 5G quality of service. Now the question is, Puneet, you got in sort of quality of service because you were all about quality of experience and things. Now why are you sort of, so we also looked at some of the applications. So this is the edge video analytic application that we have, trace generated and so on. Again, for different schemes and so on, you can actually sort of see that our response latencies and things. So this is the trade-off, right? how accurate your perceptive accuracy is and the latency and so on. We sort of do much better with respect to higher accuracy without actually sort of impacting the latency much. There was a question somewhere.
You go to previous 2 slides actually. The one before. What is yeah, no, that one, yeah, the DRP, which is seems to be doing quite well actually, except for the buffer level being high.
I think this is the again the dynamic resource provisioning without actually it just looks at without the smoothing and stuff like that is what it is trying to do. So this was trying to actually sort of you will improve the quality of service metrics mostly with that, whether it will have the impact on quality of experience and stuff.
Okay, thanks.
So, as you said that the TDD has static structure, but 5G does allow.
No. TDD does not have static structure. The standard allows you to dynamically change it.
Yes.
Nobody uses it.
Oh.
So the operators are putting a static configuration.
Okay.
And what we are saying is that the standard actually allows it. We should use it in a smart manner, right? So the dynamic TDD is something that has been in the standards. The operators don't use it. And the reason we started looking at it was that we were actually not only looking at the public 5G, we were also looking at private 5G. And that's where the application mix changes, and that's where I actually have control on my networks to be able to change these things. Yes, so it's, I'm not saying that 5G doesn't allow, if it was not allowed, we wouldn't be able to do it. The standard actually allows this, but nobody uses it.
Yeah, so just an lot being configurable in terms of how many downlink, how many guard, how many uplink. Technically, it is possible on a per TTI basis, you could change the TDD pattern, right? But there is a GSMA study done on the impact of dynamic pattern on the synchronization and the signal quality degradation, right? So in fact, they have suggested that TDD pattern is fixed at a national level as far as the public network is concerned. But if you are talking about the private network isolated in the captive, where you do not have a fear of interference, you have a dedicated spectrum, you potentially could do what you are suggesting, right?
So I actually sort of would even sort of push back a little on the GSMA suggestion on let's actually sort of make it static at the national level. Right. I think whatever static level they sort of set is not going to be optimal as the application mix changes.
Correct.
Right.
Yep.
And so I'm not saying that there are no reasons for the operators to sort of not change it or anything. Right. What I'm saying is that if it basically sort of means going back to standards bodies and say, look, this is artificial, right, and here is some data. And I'm also sort of, because of the, it's not just the overhead aspects of these things, right, with the guard intervals and stuff, there is also the notion of what kind of disruptions will it cause, right, because you can't sort of just suddenly change these things and nothing will happen. Because you ought to have your base stations which are compatible with some of these changes and things, right? So if it means that you will actually sort of turn off your base station and turn it on again when the policy changes and so on, that's a completely different story also. So I'm not sort of trying to hide these things or not sort of basically say, look, we can't, we should be doing this and so on. I'm primarily sort of just trying to sort of say, look, you can actually sort of improve and make things more optimal. And the smartness or the AI, and I also sort of take objection to AI being the only thing that is smart and so on, because I believe a lot in real intelligence as well. And the automation and the programmability of the fabric, right? So all those limitations you have to be careful about and sort of make sure that you and that's where that, remember the Q thing and the design thing that I was talking to you about, that's where it sort of all comes in. So I'm not sort of, and thank you for bringing it up. I mean, I was not sort of saying that, look, the operators are doing it for just some selfish reasons or anything. I was not saying that. That I was saying, but that staticness will only be, and again this goes back to the sort of matchmaking stuff that we were talking about, right? The GPUs are designed with some amount of memory and compute. They don't know how much the workload is going to, sort of what kind of ratio of memory and compute will it actually sort of need and so on. So there are all these similar things. I want the systems to be as dynamic as possible. Use automation and AI to be able to sort of do these things and then go from there.
Sorry, just one final observation on that. So, see, the traffic mix definitely has to determine this, but for the national level interference management, I think it is going to be semi-static rather than dynamic for the public
yes,
network. That's
yes,
the one
right.
observation.
Absolutely, right. I mean,
Yeah.
again, the other part to sort of your thing is that you have to have that awareness.
Correct.
Right now that awareness is not there. The only awareness was,
Correct.
I did this study, for all we know this study was done 50 years back, and then this is the recommendation and it stays there forever.
Right, right. By the way, 3GPP is traffic model still is remaining the same. In the view of the machine learning traffic mix change, I think there are some studies going on, but still pretty much remaining the same as the 5G traffic mix. So
Yes.
something I think needs to be looked at.
Yes,
I agree
and I
with
mean it's yes, please. Good
And
questions.
Also, the presence of, let's say, adversarial apps.
So, not as much as adversarial apps, but the smoothing functions and things that you were sort of that I was showing, that all related to how stable we want it to be and things. That's one step. We haven't formally sort of done sort of control theory stability analysis definitely, but we have shown that you can actually sort of smooth this stuff and be able to sort of get that. In terms of adversarial apps and things, no, I mean, but you can actually sort of think of this as something which is orthogonal in, especially in the cellular space, because again, you don't transmit, right? You sort of have, so that's where things are. But yeah, I mean, I think those are interesting questions to sort of figure out and study and so on. We haven't done any adversarial So again, how many times the Q, right? The watch that worked again. I also, just like Bond, try to do things in old-fashioned manner. And again, right? So here are some of the other learnings we had from this paper and things. Learn only what is latent, right? That whole sort of shaken versus stirred martini analogy and things. For those of you who have worked in networking space for the longest time, there is a very set formula that translates your round trip time and loss to the bandwidth that a TCP flow will get and so on. Should I be using AI to actually sort of figure it out? Here's the straight formula, right? Just use it. Don't sort of throw AI at some of these things, and partly because, right, again, AI actually has, and people have sort of inflated opinions for what AI can do and so on. And then this is sort of more call to action and things that I want to say. There's a lot of AI washing also happening, right? From my sort of juicer, which gives me orange juice every day in the morning. That's all AI driven these days apparently. Still sort of that orange fiber gets into my teeth. I have to use my AI driven toothbrush to get it out these days. Right? I mean, it's like use AI when you think it is meaningful. This is right. There are all the GPUs, and we can actually sort of get into discussions of agentic AI and LLMs and whatnot also, and where do you want to use LLMs and so on as well. So I think, and this is a Gartner report from last year. Basically said, look, everybody is trying to do agentic AI. 40% of that is going to fail. Partly because everybody wanted to do agentic AI. Why? I don't know. I mean, why should I like Swiggy? I order food online by clicking because that's the interface they provide. If I want to turn that into an automated engine, do I actually need the same actions like I am taking? Why don't I use standard API? Like these machines can actually sort of do standard APIs really, really well. Why do I have to actually have that LLM in there also? So basically be careful about where you use. I'm not saying don't use it. There are actually sort of nice applications and things that you can. Even with LLMs and Gen AI, if there is some amount of uncertainty or that cloudiness, right? For example, if my Swiggy order has to sort of look at my face and figure out whether I will like dosa today or idli today, go do it and use LLMs to do that. That's totally fine. But if I have never eaten idli in my life and I only eat dosas every day, that LLM is not going to give me anything. Right. So with that, I will actually sort of close and take any other questions.
Thank you very much, sir, for accepting our invitation and giving us such a fantastic talk. So in the interest of time, we'll take 2 questions and conclude.
There are some online questions, I think.
Have you did any policy optimization for the reinforcement learning algorithm?
You are basically saying, did we actually sort of try different reward functions and things and so on? We actually sort of lot of that took careful design. We actually sort of tried some, and the results we shared were based on the most optimal we could sort of figure out. I mean, it's basically a design exploration thing. We did explore the design space, but I think some of those things might be in the paper. I don't remember, but yeah, we have sort of looked at that, and again, lot of these AI models and reinforcement learning and things, we have to basically sort of also figure out what the limits to the optimization in some ways are. Right? We were able to sort of get our SLAs done in this particular case. In case of Maestro and so on, with our reinforcement learning, we were able to sort of get you very close to what would have been ground truth, or what would have been optimal with respect to the explicit QoE and things like that, right? So for us, that sensitivity analysis is only that meaningful because we were able to sort of do evaluations to show, look, we got close to explicit QoE, and that should be sort of close to what the most optimal and things are.
Yeah, so Puneet, another question. See, just to give little bit context, in 2018, I did similar work for LTE at the MAC layer by modeling based on ITU P.107, I believe, that E model, parametric evaluation of the QoS rather than MOS score, because MOS score requires a perceptual mechanism, TD is difficult to do, right? So what the ITU had done is it had modeled any customer experience abstracted into 3 parameters: latency, jitter, and the bandwidth available, right, against what is required for that application. So basis that, Of course, I didn't publish paper. We had 3-4 patents that we filed that time, and we demonstrated into some of those conferences, exhibitions. We actually did similar thing. The buffer occupancy was one of the parameters, of course, that came up. Yes, the autoimmune was possible in terms of doing the control, but it will have impact on multiple QoS parameters, so therefore we didn't do the closed loop control. I did that using a, mostly we looked into different learning models. The one additional thing that we did is automatically generating the label data set. It was not a, so that was one utility. It's all granted patents now. So maybe something that if you have not explored.
That's why I was basically sort of saying that, look, to be able to train these models on different applications and things, we are even looking at, very similar to your label data, we are looking at synthetic generation of traces and things, so that we can actually sort of train these models without having to actually sort of sit and gathering the ground truth, whether it is from the application or the users and so on. So that's absolutely right.
Yeah, so we actually demonstrated to Verizon lab in San Francisco actually for that. Okay, so they wanted to Nokia to open the API, which they did not obviously, and then it could not be done there. So
actually, that was one of the other reasons why we didn't make the assumption that explicit QoE will be available to you.
We have one question from our online participant. They're asking is, what is the secret recipe for improving the QoE from 0.7 to 0.9?
I think probably asking about Maestro. I think there is no secret recipe, right? This is what the reinforcement learning engine is sort of helping us figure out how we will actually adjust the configuration of the access category and the priority queues, and it's continuously sort of monitoring and doing it and so on. So it's not that there is a human in the loop doing it or anything. It's basically Maestro doing it. And as we had actually sort of mentioned earlier, the 0.7 to 0.9 and these numbers will vary based on what your application mix and so on is. So if I had one more application, or if I had more flows from a particular application, then those numbers will actually sort of vary also.
So finally, if you want to bond with our James Bond speaker, please do so by having a refreshments at our coffee hut. Thank you all and have a great evening.
Thank you.